Now we have uniform rod AB again, so let's draw AB length, and AB length is 5. It's weighing 20 newtons. The rod is resting on supports at C and D. AC length is given. AC is 2 meters, so somewhere here let us say. So we will get a reaction here, RC, and B to D is 1 meter, so this point is D. Again we will get a reaction at D. Then find the magnitudes of the reactions at C and D. So A bit. Ready?
Yes, sir.
So is our rod uniform?
No.
Yeah, he is telling it's uniform rod. So weight will be acting at the center midpoint, and weight is 20 newtons. And we know the length AM will be total length by 5 by 2, that is 2.5. Okay.
Yes, sir.
So in order to find the reactions, we have to take two relations, sigma V, RC upwards, RD upwards, 20 downwards. This implies, this will be equal to 0, which implies RC plus RD equal to 0. And then moment about which point? Let's take about C point. So 20 is 20 into Cm. How much is Cm? Cm will be AM minus AC.
Yes.
AM length is 2.5 minus AC length is 2, so 0.5. And this is it's going this side, so clockwise minus. The next RD into CD, and this one will go in anti-clockwise, so plus. Total should be 0. How much is CD? CD C to D. So we know AC and DB, no?
Yes.
So AB minus AC minus DB. AB is 5 minus AC is 2 minus BD is 1. So 5 minus 3 2. 5 minus 3 is 2. So CD value is 2. Okay. So negative term sent to the other side. We can 20 into Cm 0.5 equals RD into CD. CD is 2. So find RD. This 2 cancel with this, and implies that RD value is 10 into 0.5, 5 newtons, sir?
Yes.
Yes. Then substitute this over here. Sorry, this is not 0, no? This should be how much? 20 terms goes to the other side, so it becomes 20. RD is 5, then RC will be 20 minus 5, that is 15. Okay.
Yes.
So this is the solution to A bit. Then what is happening? A particle of weight 12 Newton is placed on the rod at A. So let's change the color now. A particle of 12 Newton is placed on the rod at A. So at A we are placing a particle 12 Newtons. Show that this causes the rod to tilt about C. That means we have to prove that it is tilting about C. Okay.
Yes.
So B bit. If you want this to tilt, RD should become 0. Correct?
Yes.
RD should become 0. And what else? I think that's it. So we have to just prove that sigma m about C is 0. Okay. So now take all the moments one by one. So 12 into length AC. 12 into AC. This is tilting anti-clockwise, so positive. Then 20 into Cm. This is rotating clockwise, so negative. RD will become 0 anyway. So now AC length is known. AC length is 2 meters. substitute. So 12 into 2, so of course this is equal to 0. Send this to the other side. So 20 into cm length is 0.5, correct?
Yes.
So are they same? No, they're not same, no.
Yes.
AC is 2, cm is 0.5. Let's read the question again. Show that this causes the rod to tilt about C. Okay, he's not telling it just tilts. He's just telling that it will tilt. Okay, that means it is not no longer in equilibrium. It will start moving. So what we have to do is we have to just find the value of sigma m. You should not equate it to 0. We should find the value of sigma m. Okay.
Yes.
And if sigma m is positive or negative, depending on that we can decide whether which side it is tilting. Okay.
Yes.
So let's substitute here. 12 into AC is 2 minus 20 into cm is 0.5. So do we get positive or negative answer? Positive. 12 into 2 minus 20 into 0.5. Oh, sorry, it didn't come. 12 into 2 minus 20 into 0.5. So we're getting positive 14, right?
Yes.
Positive means it tilts in which direction? Anti-clockwise, I know.
Yes.
Anti-clockwise means it is going this side only, no?
Yes.
So it's correct. So therefore it tilts anti-clockwise. That's how you have to write. Okay.
Yes.
Then next for C bit, let's change the color once again. Let's go with green now. Find the, okay, a second particle of weight 100 Newton. That means 12 Newton is already there. Along with 12 Newton, we are adding one more particle of 100 Newton placed on a rod at point E to hold it in equilibrium. So if you want to hold it in equilibrium, we have to add it this side, right?
Yes.
And 100 Newton is the weight. Distance he is asking us to find now. E to A distance he wants us to find. So this distance, let us take it as x. Okay. So in C bit we have to find that distance x. Let's solve it here. Again we have to take moment about point C. So the same values will come. 12 into AC minus 20 into cm. Now one more additional, this one will come. What is that? 100 into CE, है ना?
Yes.
100 into CE, and this one is rotating clockwise. Clockwise means minus, correct?
Yes.
So now he is telling this way, this is being held in equilibrium. This is being held in equilibrium. So because it is being held in equilibrium, the total should be 0, correct?
Yes.
So now go ahead and substitute and find it. That's it. So 12 into AC length is 2 minus 20 into CM length is 0.5 minus 100 into CE length, we are taking it as x. Total should be 0. X is the only unknown, find it. So 12 into 2 minus 20 into 0.5 divided by 100 will be equal to x. So 12 into 2 minus 20 into 0.5, 100. 0.14. How can it be 0.14? There is some mistake we are doing.
Yes.
That's the mistake. 12 into AC anti-clockwise, 20 is clockwise. 100 into acha 100 into CE we have to take now. CE value is not x. CE value is not x. What is the value of CE? CE value, if you want, you have to take AE minus CE, means AC now. AE minus AC. AE value is x minus AC value is 2, right?
Yes.
So x minus 2 should come there. So here we should get x minus 2. Okay.
Yes.
So this thing will change somewhat. So 100 into x minus 2 will be equal to this thing. Correct?
Yes.
So now do the calculation. So divide numerator 12 into 2 minus 20 into 0.5, denominator 100, and then we have to add 2 to this. Correct?
Yes.
So x value is 2.14. AC value is 2 and E value is on the other side. Correct? But it will be somewhere in here. Okay, it's not on the other side of M, it is on this side of M. Okay, but that's okay. Once you find the answer, that should do. Any doubts here?
No, sir.